Hello, welcome back to the design and analysis of algorithm subject. Today we are going to start the fifth unit. Before going to the fifth unit, we will see what we have done in the previous lecture. In the previous lecture, we saw the traveling salesperson problem using branch and bound approach. Okay, so we are going to see the fifth unit topics: NP hard, NP completeness, and we will going to see the basic concept, and we are going to see the Cook theorems. Okay, so before going to the NP hard and NP complete, first you need to know what is polynomial and not polynomial. Okay, so we will see the basic concept of NP hard and NP complete, then we will go to the Cook theorem. Okay, so here definition of P. Okay, polynomial is represent as P. The problem that can be solved in polynomial time, P stands for polynomial. Okay, fine. Now, what is the example of the polynomial? Polynomial example is searching of a key element, sorting of element, all pair shortest path problem. Okay, whatever the problem we have completed with the help of greedy method, backtracking, dynamic programming, that all are the problems are come under in polynomial. So what is polynomial? Polynomial is whatever the problem you are solving, it is solving after some time. Means every problem has some time. So the time complexity of a problem will be in last is exponential and starting is a constant. From the constant there will be an exponential. Before the exponential, it should be complete. Okay, that is called polynomial. Means the problem can be solved in a given time. Okay, that kind of problem called polynomial. Okay, so the example of the polynomial is you can write all the things like 0 by 1 knapsack problem, all pair shortest path problem, searching of keys, sorting. Okay, whatever you have learned till now, that all come under in polynomial. The next is definition of NP. What is this NP represent as? It stands for non-deterministic polynomial time. Note that non-deterministic polynomial does not stands for non-polynomial. Example: traveling salesperson problem, graph coloring problem, knapsack problem, Hamilton circuit problem. This all are the non-deterministic algorithm. Is an algorithm in which each operation generate one or more result. This algorithm does not produce unique result. Okay, so polynomial means it will be a unique result. Like if you are searching for the key, then you need to only search for the key only, you will get only the one result. If you are sorting, so you can sort all the element in ascending or descending, that is one. All pair shortest path problem, this is also is a polynomial. But when you come to the non-deterministic polynomial time, so traveling salesperson problem, the person can go from anywhere and it should visit the vertices once and reach to the starting point. Okay, graph coloring problem, knapsack problem, Hamilton circuit problem. Okay, this all kind of problems are come under in non-deterministic polynomial. Okay, remember polynomial example is searching for the key, sorting, all pair shortest path problem, and non-deterministic polynomial is traveling salesperson problem, graph coloring problem, knapsack problem, Hamilton circuit problem. Okay, so remember this is not non-polynomial, it is not non-polynomial, it is a non-deterministic polynomial. Okay, so here why we are saying this is NP, because it gives the result more, one or more result. Okay, so it does not have any unique result. Every time it will be changed and it will get the one or more result. Because of that, it is a non-deterministic polynomial. NP. NP class problem can be further categorized into NP complete. This is the main topic. NP complete and NP hard. Okay, this is the two things are there in NP. What is this NP? NP complete. Okay, we know what is NP. NP is a non-deterministic polynomial. But what is NP complete? A problem is said to be NP complete if and only if it satisfies the following two conditions. When we will say NP complete, when the given two condition is satisfied. Let's check it out. The condition. Condition number 1. Problem should be present in class NP. So your problem should be available in class NP, non-deterministic polynomial. There your problem should be available. Second one is, each problem should also be solved in polynomial time. Okay, whatever the problem we have in a NP, that also we can solve, that also we can solve in a polynomial time. What are the two conditions? First thing is it should be present in NP, and the second one is it should be solved in a polynomial time. When I see you the graph of P and NP relationship, then you can easily understand the concept. Okay, however, there is no one who can prove whether NP complete problem can be solved in polynomial time or not. Okay, there is no one who can prove whether NP complete problem can be solved in polynomial time or not. Okay, we cannot say that. So here, hence this type of problem are unsolvable problem of mathematics. What we will say, this type of problems are unsolvable problems of mathematics. Next one is one of example NP complete problem is graph isomorphic. Okay, graph isomorphic. It is a problem of graph theory that check whether a graph isomorphic exists among two graphs or not. Another example are traveling salesperson problem, knapsack problem, graph coloring problem. This all are come under in NP complete problem. Okay, NP complete problem. So what is NP complete problem? NP complete problem is has the two condition. In these two condition, first one is whatever you have a problem that should be in NP, and the second point is that problem should be solved in a polynomial time. We'll move to the next. NP hard. NP hard, a problem is said to be NP hard if and only if it is solved by polynomial time. Okay, it does not have any more condition. It is only one condition, that is it is solved in polynomial time. Whenever an NP hard problem is solvable in polynomial time, then each NP complete problem can also be solved in polynomial time. Okay, what it is telling, whenever a NP hard problem is solvable, if we can solve the NP hard problems in polynomial time, then each NP complete problem can also be solved in polynomial time. Okay, next one of the example of NP hard problem is traveling sales problem. It is a problem in which cost of the travel between two pairs of cities and number of cities are provided, so it's need to find a path to visit all the cities and return back to its starting city with less cost. Okay, what already we have done this traveling salesperson problem by using the branch and bond also. Okay, it is a problem in which the cost of traveling between two pair of the cities and number of cities are provided, so it's need to find a path to visit all the cities and return back to its starting city with less cost. Okay, so we need to get the less cost, and it should be visited all the cities, and all the cities should visit only once and reach to the starting point. This is the problem of the traveling salesperson problem. Some other example of NP hard problems are halting problem. Okay, there is one type of problem is there, but that is not in your syllabus. That is halting problem. Okay, however, each NP complete problem is said to be NP hard, whereas each NP hard problem cannot said to be NP complete problem. Okay, here each NP complete problem is said to be NP hard, whereas NP hard problem cannot said to be a NP complete. Okay, so whatever the NP complete problem is there, that is we can say it is NP complete as well as NP hard. But when you come to the NP hard problem, so we cannot say this is NP complete. Okay, so this is about the NP hard. Okay, so this is NP hard. Now, what is this non-deterministic algorithm? If we see, we are telling non-deterministic polynomial. So what is non-deterministic algorithm? It is an algorithm in which each operation generates one or more result. Okay, whatever the problem you have, if we are getting the more than one result, one or more result, then it's said to be a non-deterministic. This algorithm does not produce unique result. Okay, this is also one type. Means when we will say it is non-deterministic, when it is provide one or more result, or it does not have a unique result. This algorithm consists of two stages. First one is non-deterministic stage, second one is deterministic state. Okay, the first one is non-deterministic stage. This stage is also known as guessing stage. Okay, non-deterministic stage is also known as guessing stage. It can create an arbitrary resultant string which can be considered as a candidate solution. Okay, which can be considered as a candidate solution. When you come to the deterministic stage, this stage is also known as verification stage. Okay, this stage is also known as the verification stage, and it verified whether the candidate solution is actual or not. Okay, actual or not. But what is happening in the non-deterministic? In the non-deterministic, arbitrary result. Okay, but here we are checking the actual solution or actual result. Okay, in order to do this, it's take candidate solution as input and return output, which can be either yes or no. Okay, it will take as candidate solution as a input and resultant output, which can be either yes or no. So in the algorithm, if we see the algorithm, we have the 2 points. 3 points. Okay, we have a choice. Okay, fine. So here in this algorithm non-deterministic. If it is asked in the exam, tell something about the non-deterministic algorithm, so you need to write the algorithm this. Then only you are going to get the marks. So very simple algorithm. In this algorithm, we are using the three things. What the three things we are using here? Just here, I am using the choice, okay, as my choice, and success and failure. These three things we are using in the non-deterministic. First one is guessing stage for I is equals to 1 to m, okay, to s of I is equals to choice of I. So here it will take a choice guessing stage, then after that it will verify. What is a verify? If s of I is equals to y, then write I. Okay, means y is like yes, example. So here write I, then it will be display the success. Otherwise it will display the write 0 failure. This is not I, this is 1. Okay, so here just now we have completed the guessing stage and verification stage. In the guessing stage is non-deterministic and verification stage is a deterministic. Okay, so in this we are using the three things: choice, success and failure. Okay, so this is simple algorithm we need to write at the time of exam. And here in non-deterministic algorithm can be specified using the following three functions. Okay, what are the three functions? As I told you, first one is choice, failure and success. Okay, so what is choice? This function is used to select an element from the given set S, and this selection is done randomly and assign the selected value to a variable. Okay, what it is doing? It is select an element from the set S. There will be some set. From there it is selecting a element and randomly it is assigning the selected value to a variable. Okay, next, failure. The function is used to denote an unsuccessful completion. Okay, this is we are considering failure is unsuccessful completion. What is success? The function is used to denote as successful completion, means whatever we were doing that we have completed here. So whenever it will be success, then it will be a successful completion. If it is failure, then it is a unsuccessful completion. And what is choice? With the help of choice we are getting the value failure or success. We are assigning to the value we are from the element S we are taking the value and assigning to this variable, and we are checking it is a failure or success. Okay, and here if we take the example of non-deterministic for searching, okay, if we take the example of searching in non-deterministic algorithm, consider a problem while searching a specific element E, okay, from a set m of 1 to x should be greater than or equal to 1. There should be some values more than 1, and given the resultant output and the index I of the searching element. Okay, for this, for the searching non-deterministic algorithm, we are writing the algorithm. Here what it is doing, algorithm search E. Okay, E is a element from the what you are searching. Okay, I is equals to choice 1 comma x, means from 1 to x, and if m of I is equals to e, whatever you are searching, if it is same, then output is I, whatever the I is there, that is the output and that is a success. Element 0, failure, means if m of I is equals to e, if it is true, then output will be 1, okay, and it is a success, else it is a failure. Okay, so this is about the simple example for searching in non-deterministic algorithm. Okay, okay, so here np hard and NP-complete classes and relationship between p, np, np hard and NP-complete. Okay, this all the things we are going to see. Okay, relationship, how we can say, and how can I relationship. Okay, so here complexity of algorithm can be calculated by the length of input to the algorithm, which is taken as a parameter. Okay, hence based on the complexity of algorithm are classified into two classes. Okay, based on the complexity, it is divided into two classes. The first one is complexity class is P, complexity class NP, polynomial and non-deterministic polynomial. Okay, so here what is complexity class P? The complexity class P is composed of those problems which are computed in polynomial time to get the solution. Okay, polynomial time, to compute in polynomial time. More precisely, class P problem can be solved compute in order of n power k, order of n power k, where k is some constant and n is the size of input to problem. Okay, what is complexity class P polynomial? That is, should be computed in a polynomial time to get the solution, and if we more precisely, class P problem can be solved compute in order of n power k. Okay, now the second one, complexity class NP. The problem in this class are only verifiable but are unable to solve in polynomial time. Only verifiable, whatever the problem is there, that can be verified but unable to solve the problem in polynomial time. Okay, only verifiable but unable to solve the polynomial time. Class NP problem are the set of problems which could be solved by non-deterministic algorithm. So what is non-deterministic algorithm? In non-deterministic algorithm we have three things. First one is a choice, second one is failure, third one is success. With the help of non-deterministic algorithm we need to solve the problem. Okay, that we can say complexity class NP, non-deterministic polynomial. Okay, class NP problem are said to be a problem which could be solved by non-deterministic algorithm. Okay, so this is complexity class P and complexity class NP. Okay, now we will see the relationship between P and NP. Okay, first we will see the relationship between P and NP, Then afterwards we will see the relationship between P and NP, NP hard and NP complete. Okay, deterministic algorithms are considered as a special type of non-deterministic algorithm in which conclusion are as P is a subset of NP. Okay, P is a subset of NP. However, in computer science, an unsolvable problem is given as either P is equals to NP or P does not equal to NP. Okay, the two are there, like unsolvable problem is given either P is equals to NP or P does not equal to NP. Okay, it is assumed that the polynomial time deterministic problem are possible for those problems that belongs to NP class, but such type of problem are yet designed as the proof of the statement. That means still the research is going on NP, non-deterministic polynomial. Still the research is going on in it to finding the best solution and how to solve in a given like to reduce the time. Okay, that should not use the non-deterministic algorithm. Without using the non-deterministic algorithm, how can we solve the problem in P, polynomial time? Okay, so consider P does not equal to NP is a consider P is equals to NP is apparent. Assuming P does not equal to NP, the relationship between P and NP is shown in the figure. So you can see this figure here. What does it mean? NP are larger than P. NP means still the research is going on. Okay, because we don't know the non-deterministic polynomial problems. From that only we have some polynomial problems like searching, okay, sorting, etc. So this is polynomial. So can we say P is a subset of NP? Yes, we can say P is a subset of NP. Okay, so the relationship between P and NP is P is a subset of NP. We can say P is also a NP. Okay, so from the NP, P is a small part polynomial. Okay, so this is a relationship between P and NP. Okay, like if we go with the relationship between, okay, relationship between P, NP, NP hard, NP complete. Let's see the relationship between P, NP, NP hard and NP complete. Okay, so what we are telling, the first one is the relationship what we have done on the top, the same thing we need to do here. Okay, this is NP and this is P. Okay, P is a subset of NP. Now we need to do the relationship with NP hard and NP complete. So here I will change the color to green, and here this is a NP hard. NP hard. Okay, this is NP hard. But when you come to here, okay, what is the intersection between these two circles. Okay, this one is a, I will take the, okay, fine, NP complete. Okay, so this is polynomial time, this is non-deterministic polynomial time. Okay, NP hard and NP complete. So this is a relationship between this four. Okay, so that's why we are telling whatever the NP complete problems are there, that we can say the NP hard, but whatever the NP hard problem, we cannot say the NP complete. Okay, as we have studied above. Okay, NP complete, all the NP complete problem we can say as a NP hard, but all NP hard problems we cannot say is a NP complete, because what is the size of NP complete? Only the intersection between these two circles, that is only a NP complete. Okay, because of that we are telling whatever the NP complete problems are there, that is non-deterministic polynomial hard. Okay, so this is a relationship between P, NP, NP hard and NP complete. Okay, so this is all about the P, NP, NP hard, NP complete, and now we are going to see the Cook's theorem. What is Cook's theorem? Now, as we just now we said, P is a subset of NP and P does not equal to NP, but P equal to NP will be the possible if we use the Cook's theorem. Cook's theorem states that if P is equals to NP, then satisfiability lies in P. Okay, satisfiability lies in P. It is known that satisfiability is in NP, hence if P is equals to NP, then satisfiability is P, and also vice versa, that is if satisfiability is in P, then P is equals to NP. Okay, so whenever P is equals to NP, the satisfiability is P, and also vice versa, if satisfiability is in P, then P is equals to NP. To prove this, Q bracket A comma I has to be formulated from polynomial time non-deterministic algorithm A and input. What is A? A is a algorithm and I is a input. Okay, when the length of I is n, and the time complexity of algorithm A is equals to P of n, then the length of the Q is equals to order of P power n of n log n. So what is this? Order of P power 4 of 4. Okay, order of P power 4 of 4. Okay, the deterministic algorithm determine Q and whether state Q is satisfiable or not. What deterministic algorithm do? Whether state Q is satisfied or not, it will check. If order of Q of M is time required to formulate length M is satisfiable, then complexity of the algorithm order is order of P power 3 of n log n plus cube of P power 3 of n log n. Okay, if we have a q of m is time required for the formulate length for m is satisfiability, we need to add the previous one and this. Then if the p is satisfiability, then the complexity of polynomial time function will be order of Rn. Okay, polynomial is satisfiable, then complexity of polynomial time function will do order of Rn. Hence its satisfiability is for p, then a deterministic d in p can be obtained for each of the non-deterministic algorithm is in NP. Thus the satisfiability is in p, then p is equals to NP. Okay, d is a deterministic in polynomial time can be obtained for each of the non-deterministic algorithm a is in NP. Thus if satisfiability is in p. Okay, so p is equals to NP we are telling when we are using the Cook's theorem. Okay, definitely this Cook's theorem will come in the exam at least for the 2 marks for the definition. Okay, or this is important topic in 5th unit. In 5th unit, this NP hard and NP completeness and the basic concept of this is very important. Okay, so NP hard and NP complete, and we saw the basic concept of uh, polynomial time, non-deterministic polynomial time, and NP hard, NP complete, and Cook's theorem. Okay, so this is all about the today's lecture. And Cook's theorem is started by the Cook-Levin theorem. Okay, is also known as Cook's theorem. So this is about the today's lecture. Okay, so what we have completed: NP hard and NP completeness, basic concept, like what are the basic concept we have completed, like what is P, NP, okay, and complexity of P, complexity of P, and NP, complexity of NP, what is P, NP, and NP hard, NP complete. Okay, and we saw the relationship between P, NP, NP hard, HARD, NP hard, and NP complete. Okay, and we saw the Cook's theorem. Like what is we are telling here? We are telling here P is a subset of NP. But when you comes to the Cook's theorem, what we are telling? P is equals to NP. Okay, when you comes to the Cook's theorem, when you come to the basic concept P and this is a P subset of NP. Okay, thank you very much. Today's lecture is going to be finished here. We're going to see the next topic of 5th unit in the next class. Thank you very much. We'll see you in the next class.